Hi guys, Assalamualaikum warahmatullahi wabarakatuh. So today I'm going to teach you about heat. In this topic we'll learn about 4.2, that is specific heat capacity. So what is heat capacity? Okay. Ta-da! So heat capacity, or Big C, is quantity of heat needed to raise the temperature of the object by 1 Celsius. Okay, so let's say we have a bowl and heat capacity state that quantity of heat, let's say this is the quantity of heat needed to raise the temperature of the object by 1 Celsius. Okay, so that says, okay, let me watch this again. So heat capacity, quantity of heat needed to raise the temperature of the object by 1 Celsius. But how do we find the heat capacity? Okay, we can use this formula. Big C equals to Q over delta theta. Okay, so what is Q? Q is the amount of heat, and delta theta is the change of temperature. And the unit for this one, for the specific heat, is JC -1. Okay? And what additional information that you should know about specific heat is that when the mass of the object increase, so the specific heat of the object also increase. Okay, for example, is, let's say I give you 2 kettle. So one kettle A, and this is kettle B. So kettle A, I only put a little amount of water, and kettle B, I put like full amount of water. So for these 2 kettle, which one did you think that it will boil faster? So of course the answer is A. This one, let's say it's gonna take 10 minutes to boil, but for kettle B it's maybe take 30 minutes to boil. So when the mass of the object increase, specific heat of the object also increase. So you understand what I mean?
Yeah.
Okay, so what is the daily situation involving heat capacity? For example, your mother cooks soup, and then you put the soup into 2 different size of bowl. One very big bowl, and one is smaller one. So when you put the soup into this bowl, you will find that this soup will remain hot while the other one is already cold. Let's say you put in the table in 5 minutes. So you'll find out that the soup in a big bowl is still hot while the smaller one is already cold. So that is daily situation involving heat capacity. Okay, so let's move to specific heat capacity or small c. Okay, so specific heat capacity or small c is quantity of heat needed to raise the temperature of 1 kilogram mass of the substance by 1 Celsius. So we could find the specific heat capacity or small c by using the equation C equals to Q over M delta theta. So Q is amount of heat, delta theta is the change of temperature, and M is mass of the object. So the unit is heat is joule. Delta theta, the unit is delta C or maybe K, and the mass of object will use kg. So the unit is either J, kg, -1 or maybe, or C, C -1, or maybe J, kg, -1, K, -1. Okay? And for your information, maybe sometimes the question will not give you the Q, like directly Q, so we have to find the Q. So we can use this equation, Q equals to MC delta theta. Okay, so you have to bring this one to the up, and then you will get this equation, and you will get the C. Okay, so we move forward to application of specific heat. So the first one is selection of building materials by climate. For example, for hot climates, wood are usually used to build the house. Okay, this because wood has high specific intensity and it makes the house less hot. Okay, next, cooking utensil. For example, hot wok, this is the wok, I usually use at the stall or the restaurant because it has very low specific heat capacity and it make the temperature increase so that it will take less time to cook the food. Okay, so there also have a few of application of specific heat capacity, that is sea breeze, land breeze, outer layer of space capsules, and also a car radiator system.